Let's take a look at these two examples. Again, we have to divide every single term from the numerator by the denominator. Okay, so I'm going to rewrite this problem, and this is going to look like this. Minus 42 x to the third y to the third divided by minus 6 x to the second power y to the third plus 36 x to the fourth y to the fifth over negative 6 x to the second y to the third minus 48 x to the fifth y to the seventh over negative 6 x to the second y to the third. This is going to be equal negative divided by negative is positive. 42 divided by 6 is 7. X to the third over x to the second. I have the same base, division. Anytime I have the same base and division, I have to keep the base and subtract the exponents. 3 minus 2 is equal 1. We don't write the exponent 1. Y to the third and y to the third, they are going to cancel out each other. I finish with the first term. Positive divided by negative is negative. 36 divided by 6 is 6. X to the fourth divided by x to the second. Again, I have the same base. I have to keep the base and subtract the exponents. 4 minus 2 is equal 2. And I have y. Again, I have division. I have to keep the base and subtract the exponents. 5 minus 3 is 2. I finished the second term. Next, I have negative divided by negative gives me positive. 48 divided by 6 is 8. Again, I have x. The same base, I have to subtract the exponents. 5 minus 2 is 3. Y. Again, I have the same base and division. I have to keep the base and subtract the exponents. 7 minus 3 is 4. This is the solution to my first problem. Let's take a look at the second example. Again, we have to divide every single term from the numerator by the denominator. That's why I'm going to write 4a to the second power b to the third divided by 2a to the second b. Subtract this term divided by this one. So I have 6a to the third b to the fourth over 2a square b plus, I have to divide this term by this one. I have 2a to the third b over 2a square b. 4 divided by 2 is 2. A squared divided by a squared is 1. Okay, I'm going to cancel them out. B, anytime there is no exponent visible, there is always invisible 1. I have to keep b, because I have division, the same base, I have to subtract the exponents. 3 minus 1 is 2. Minus 6 divided by 2 is 3. A, this is my base, I have to keep the base and subtract the exponents. 3 minus 2 is 1, I don't write 1. B, remember, anytime there is no exponent visible, there is always 1. I have to keep b and subtract the exponents. 4 minus 1 is 3. Plus 2 divided by 2 is 1. These two are going to cancel out. I have a and a square. I have the same base, division. I'm supposed to keep the base and subtract the exponents. 3 minus 2 is 1. I don't write exponent 1. B and B will cancel out. Okay, so this is the solution to my problem.